Hello everyone, hope you are doing good. So today's topic is, as you can see, the cerebral cortex. Before proceeding to this topic, first thing first, please excuse my drawing. It's very bad. As you can see over here, I have drawn the diagram by looking at just copying it from the book. Still, I'm not able to draw it properly. So please excuse me for that part because my drawing is very bad. If there is any word that is the worst form of the word, you can put that word for my drawing. Okay, so that was on lighter note. On serious note, coming to this thing, cerebral cortex. Throughout your school life, you read about all these things, the cerebral hemisphere and the cerebral cortex. So regarding this initial stuff, we will just have a brief quick overview, and after that we will go into detail. So the cerebrum, the brain itself, it's a cerebrum. It consists of two cerebral hemispheres, and those two cerebral hemispheres, if we look at them, they are separated from each other on the superior aspect. Like say this is one cerebral hemisphere left side, this is the right. So on the superior aspect, there is a fissure in between those two cerebral hemispheres. And what passes over there? Like the covering is dura mater. So there is a fold of that dura mater in between two cerebral hemisphere on the superior aspect medially. That is called as falx cerebri. Okay, falx cerebri, because it is separating two cerebral hemisphere. Falx cerebri. That is the superior aspect. Now on the inferior aspect, these two cerebral hemisphere, they are connected with each other through corpus callosum. Corpus callosum. Okay, corpus callosum. So if we look at the cerebral hemisphere, we can say they have got three poles, and three surface, each cerebral hemisphere. So pole is like this is, first we will look at the surface. Like if this is a cerebral hemisphere, the outer surface, this superior and lateral, this is called as superolateral surface. So one surface is superolateral, the other one, that is the medial surface, and the third one is lower one, that's the inferior surface. So there are the three surfaces: superolateral, medial and inferior surface. And this is the lateral aspect of the cerebral hemisphere. So if we look over here, there are the three poles. These pole, anteriorly this is frontal pole. Okay, frontal pole. Posteriorly, this is the occipital pole. And in between or the midway, there is one more projection over here. This is temporal pole. So three poles and three surfaces, that constitutes one cerebral hemisphere. Now, if we look at the cerebral hemisphere, the outer aspect, say this is cerebral hemisphere. Okay, this outer aspect, outer 2 to 4 millimeter, just a layer of 2 to 4 millimeter. How much? 2 to 4 millimeter of the gray matter. It consists of gray matter. That 2 to 4 millimeter of the gray matter is called as cerebral cortex, and that 2 to 4 millimeter is the one that makes us human being. If we remove that 2 to 4 millimeter, we are in the least evolved species in this, on this planet or in this universe, whatever we can say. So 2 to 4 millimeter, only because of the 2 to 4 millimeter, that gray matter, that makes us the most evolved species, at least on the earth. Can't say about the universe, but at least on the earth we are the most evolved species because of this 2 to 4 millimeter. So next time if anybody says, come on yaar, it's just a matter of few millimeter, so ask him that 2 to 4 millimeter of his or her cerebral hemisphere. This constitutes the cerebral cortex. So this cerebral cortex, this 2 to 4 millimeter, it has been, it's convoluted. And what is the purpose of this convolution? The purpose of this convolution is it increases the surface area. Because of this convolution, our cerebral surface hemisphere, the surface area is 2400, almost 2400 or 2500 centimeter square. And this folding, these convolutions, this is called as, that folding is called as the gyrus. The folding is called as the gyrus, right? And in between two folding, this depression, this is called as sulcus. So gyri and sulci, it makes the convoluted appearance of the cerebral cortex. And there are so many multiples of these sulci and gyri present in everybody's cerebral hemisphere. And few of them, they are more or less consistent, or they are more or less present in each and every human being. Based on those prominent sulcus, we have divided the cerebral hemisphere, the cerebral cortex, that part, into different lobes. There are the four major lobes: frontal, parietal, temporal and occipital lobe, right? Frontal, parietal, temporal, occipital. So on the outer aspect, the lateral aspect, this is the lateral aspect, this is also the lateral aspect, this is medial aspect. Okay. So if we look at this diagram, on the lateral aspect, there are two major sulcus. One is central sulcus. Central sulcus, or the central sulcus of Rolando. Sulcus or fissure is one and same thing. So central fissure of Rolando or central sulcus of Rolando, not Ronaldo, Rolando. The second one is Sylvian sulcus. This is also known as lateral Sylvian sulcus, or just simply lateral sulcus. So lateral sulcus, anteriorly it divides the cerebral hemisphere into frontal and temporal lobe. This part, anterior, or this is called as rostral. Rostral means, it's easy to remember rostral, toward the nostril. So anterior part. So rostrally, the lateral Sylvian sulcus, it separates the cerebral hemisphere into the frontal and temporal part. And it proceeds backward. On the posterior aspect, it's not a complete one, it extends up to this much. So on the posterior aspect, it separates the cerebral hemisphere into parietal lobe and temporal lobe. And this parietal and temporal lobe division, in the posterior most aspect, this black part, this is just an imaginary line, because this lateral Sylvian sulcus not extends up to this one. So we just draw an imaginary line extending this lateral Sylvian sulcus toward the back side. So it separates the cerebral hemisphere into parietal and temporal. Then the second one, the second prominent sulcus, it is almost perpendicular to the lateral sulcus. This is the central sulcus, or central sulcus of Rolando. We simply call it central sulcus. So anterior to this central sulcus is the frontal lobe, and posterior to it is parietal lobe, right? Parietal lobe. Now this parietal lobe and temporal lobe, they have been divided based on lateral Sylvian sulcus. This posterior most part of the cerebral hemisphere, this is called as occipital lobe, and there is no prominent sulcus separating it from the parietal and temporal on lateral aspect. This parieto-occipital sulcus, this is just extension coming from the medial aspect. If you look at the medial aspect, this is the medial diagram. So medially, this parieto-occipital sulcus is prominent, and it separates this occipital lobe from the parietal lobe. And on the lateral aspect, it extends, it just comes up to this one. And if we try to draw one more imaginary line, that separates the parietal from occipital lobe on the lateral aspect. Now, if we look on the medial aspect, there are three prominent sulcus on the medial aspect. One is this cingulate sulcus. Cingulate sulcus, it separates this gyrus. This part is corpus callosum. This orange one is the corpus callosum. That's the connection of two cerebral hemisphere, and that connection is made of white matter, right? White matter. So surrounding that corpus callosum, this gyrus, it is separated from, if we look at this is frontal and parietal. So it is separated on the medial aspect from the frontal and parietal lobe by the cingulate sulcus. This one is called as cingulate gyrus. Cingulate gyrus. And it separates from the frontal and parietal. And this parieto-occipital sulcus, it separates this part of the parietal lobe from occipital lobe, right? Now, the occipital lobe, it has got a prominent sulcus on the medial aspect, that is called as calcarine sulcus. And this calcarine sulcus, it separates occipital lobe into two parts. Superiorly, the cuneus sulcus, the cuneus gyrus, sorry, not the sulcus, the cuneus, and the inferior, below this calcarine sulcus, this is lingual gyrus, right? So that's how the cerebral hemisphere or the cerebral cortex, it has been divided into different lobe. This one, this cingulate gyrus, this is not part of either the frontal or the parietal or the temporal or the occipital lobe. It's like we can say it's an artificial lobe, we can call it, that is the limbic. When we will talk about the limbic structure, then the cingulate gyrus is one of the part of the limbic system, the limbic cortex. Okay.